Hello, welcome back to Blender Sushi Live Noding. In this episode, we're gonna take a look at a node setup that's kind of creating this kind of structure. What is this exactly? This is actually just like a cylinder, but being hacked by Squarechop. So we know that cylinder is really, um if you imagine like a circle at the top and a circle at the bottom, cylinder is really basically just interpolating between those two circles and then to make a cylinder. And sometimes you have the top and bottom, sometimes you don't, and so it's just like I don't know how you call it, but just you can control the top and the bottom circle and it will interpolate in between. And in the previous live noding I kind of mentioned that I wish cylinder can actually have like a middle part that you can kind of control. So this is one of the way you can do this. So I can control the number of the divisions there, and then I can control the stepping. That's actually, there's a noise going through the cylinder, so it's in the way it's kind of like displacing the cylinder. I still have control for the top and the bottom, and the height actually no problem. This is very efficient. So let's just try to see how I create this setup. It's not actually that hard. I'm gonna save this just in case if I actually fail. So the idea here is to have start with a cylinder and then kind of break the cylinder into separate parts, and then kind of do something with the parts and then combine it together. So Squarechop cylinder hack. So this is supposedly really simple. I try to do it like super fast. So that's a normal cylinder with a cut, and we have top, bottom, control, and we have the vertices. Okay, let's give it like 12. We have subdivisions, maybe have 2 subdivisions for now, and the height. Okay. The idea is, of course, like I said, I'm gonna split the cylinder into its basic components, because this guy itself is already like a parametric kind of object. So we start with this 12 vertices of circle at the top and 12 at the bottom. They're kind of being interpolated in between, and we have that kind of pattern happening, 12 12 12 points, so we can kind of split that. So that's the first idea. If I split the data, let's cut this and split that. I'm kind of sometimes guessing what's the number I needed. I think split level 1. Let me try. Actually, it's not the split level that matters, it's actually the split size. We want to split it every 12 vertices, because this is a number. Okay, 12 12. And then once this guy is being split, we can of course list the item. You can see here. So we have like 4 kind of point circles. So that's actually correct. So you can also see on the, if we use the stethoscope 2, plug that in, list of 12 items, 12 12 12 12, and each one have of course the points of the circles. So that's good. We can work with this guy. All I need to do is kind of want to do the scaling of each of the circle, and then combine the circle back. So vertices goes in there. We know that there are 4 of them. Plug into this guy. Okay, that's the end result. If we plug in the polygon, it's kind of recreating the cylinder, but not yet there. So I want to control each and every one of these. How do I do that? Let's see. You can perhaps use the list input. Maybe the center we don't know yet. Maybe yeah, for the center we use let's say use random vector, count of 4, and then the seed. Okay, we don't care about the seed for now. The factor So you see what's going on at the moment. It's not actually doing it properly. It's almost like multiplying. Now we have like a 4 by 4 circles, and we end up with a multiplication of this guy. This is not what we want. We actually want to split this as well, so they can operate on each one of the circle. So, and we kind of need to split it with 1 for this guy. So now this is more correct. You can see the circle is now being pushed random with a. This is the center points of its scaling. Later on, we might actually need a random number generator for each one of this guy as well. So if I before I do that, I really want to have the center of each of these items instead of random vector. We don't want a random. So how to get the center points? We can use the bounding box, I believe. So for these 4 guys, get the bounding box and get the mean center. And then now you can see I'm kind of scaling based on the center of each one of these. And then for the factor, I can use random number generator, perhaps. If I am using like list input, I believe I can do that as well. List input, and then give it like 4 input in float, plug that in, and I can control. There you go. This is happening again. Instead of scaling them one by one, I kind of scale it, kind of recreating duplication for each one of them. This is not what we want. Maybe this is what you need at some point, but not for this case. We really need to split it. So list split size 1, and now we have what we want. So we can scale each part separately. Okay, cool. So list input works. So random number generator will also work if we give it the right value here. 4 size is 4, and then we have seed, and we can control the low and the high. Cool. Okay, so that's working, and then we almost kind of done, except that you notice that if I just plug in the polygon there, it doesn't quite work because we need to combine this value back. After we separate it using list split, we need to use list join to put it back together. So now the recipe is kind of okay. Now it's correct, and then we have the cylinder back, but each of the components has been adjusted. So it's almost like if you have like a soup, and then the soup, you kind of filter out the soup, and then you want to kind of adjust the ingredients of the soup, and then once you're done with that, you kind of put the soup together, and then it becomes a new kind of object. So that's the point. And then if you want to make it very like parametric as possible, you need to make sure the number that's actually corresponding to each other is combined together. So in this case, the split size needs to match the number of vertices. So that's important. And then the next one, what do we have? So that's we can control now. And then the height actually separate. The subdivision actually matters as well. It's basically the subdivisions you need to add 2 to the subdivisions to get this 4, because it's 2 more is for the top and the bottom. So if we have like math here, actually math, and then we have a number, integer number. If we have 2 here, this guy should get 4, but really what happening is we need to have 4. So 1, 2, 3, 4, and then we minus 2. So we get this subdivision, and then 4 goes in there. So now no matter how many divisions, how many repeats, it will still work properly. So that's the radius top and that's radius bottom. It's kind of repeating itself. Okay, so random number, so we have everything is correctly designed. Bounding box works, edit this join. Okay, cool. At this stage, really, it's up to you how you wanna kind of hack this cylinder. Currently, it's right. We are just scaling each one of the circle of the cylinder randomly. But if you want, you can also use like a noise, vector noise, and give it like a scalar output. This is asking for vertices, so I can use like a line, and then line, the number of vertices is based on this guy, vertices out, and then the noise can actually go there to control the cylinder. So this is actually, that's pretty much it, what's happening. Instead of a random value, now we have noise that's going through the cylinder. Then line, let's see, to make it more correct, maybe I need to rewire this line. And then using vector math, I can control the noise in the z-axis. There you go. That's pretty much it for this math here, and then give a point to. You can also use sine wave and all kind of functions just to drive this cylinder. It's very efficient, very fast, and yeah, this is actually one of the strengths of Spreadshop. It's so easy to create something like this now. That's normally it's not actually that easy to create. There's this thing in Spreadshop, you can easily bake everything you see as from the viewer. Just click on this guy, and you get the surface here. You can smooth it. With a cylinder, sometimes it has the bevel part, so you want to use the bevel, perhaps, to make the top part a little bit nicer. Oh, that's interesting. I have a feeling that this cylinder is a little bit funky. Maybe it has like some kind of doubling that I didn't realize. I don't know, seems okay. If I like remove double, nothing. Yeah, cylinder just behaving like normal cylinder, but it's just the bevel probably doing it something funny. If I use wireframe, still like a normal cylinder. So I'll quickly matcap this and only render, take a snapshot. There you go. That's one way you can kind of hack into cylinder using Spreadshop. Since everything is parametric, if the geometry has some kind of pattern in the structure, Spreadshop is really good at kind of goes inside, separate every components, and then do something with the components and put it back together. So yeah, this is one of such example. Hopefully you find this useful. If you have any questions, suggestions, just let me know, and I'll see you in the next video. Thank you.